Hi everyone, welcome back. In my previous video, I provided a brief overview and context of UAVs in our society. Today, I will be going over some of the problems that we could potentially be facing with the widespread adoption of UAVs. At a high level, we could categorize these problems into three main areas: safety, privacy, and scalability. Now, the first issue deals with privacy. One of the problems people tend to have with drones making an appearance in our society is this notion that privacy may be compromised. One example is this idea of paparazzi drones, the objective being to simply follow and photograph celebrities. Criminals and other individuals may use this kind of technology for purposes of stalking, harassment, and other forms of malicious intent. Ultimately, the issue with privacy is it has a lot to do with the way people view and perceive this kind of technology. Keep in mind that technology is just an enabler. There needs to be proper regulatory, legal, and other controls in place to make sure people are aware of their privacy invasion. People are given choices and options to opt in and opt out of certain situations. At a minimum, they are at least made aware of who has access to them, their information, and for what purpose. As you can see, the area of privacy is pretty huge. I will provide a more detailed solution approach in my next set of videos on how this can best be addressed. The next point deals with safety. Safety is definitely one of the most important issues when it comes to UAVs, because it's one of those things that quite honestly has to be there in order for people and the community to be safe and accepting of UAVs in our society. Specifically within safety is this whole idea of preventing accidents and collisions. Because when two or more UAVs collide in the air, then it's not just the damage that's done to the UAVs that can be problematic, but it's also the civilian lives that can be endangered and at stake from the debris of the collision. But before getting into the nuances and complexities of UTM collisions, I think it's really important to understand the basics of what exactly a collision is. Now, a collision at the bare bone level is when two or more objects, in this case UAVs, are at the same place at the same point of time. In order to prevent something like this from happening, there needs to be some form of communication that's established between the UAVs. If you draw an analogy to driving, for example, a lot of times at stop signs, you'll notice that a driver signals to another driver to go ahead simply by a hand wave or a gesture. Even while changing lanes, a driver generally signals his or her intention to switch lanes in order to prevent a collision. This same sort of idea and communication should be implemented and used by UAVs. And I think an example would really best help illustrate this point. Suppose you have a UAV traveling east to west and another UAV traveling north to south. Is there a possibility of collision? Yes. But by enabling some form of communication between these UAVs, we can reduce the likelihood of such a collision from happening. So really, if you look at it, the crux of the solution here is communication, communication, and communication. Fortunately for us, the upside to communication is that cell phone companies have already solved that problem for us. So really, the next step is to expand this and implement this kind of technology to UAVs. So now that's the scenario when two or more UAVs collide with each other. But then we also have to consider and take into account when a UAV collides with, let's say, a bird. If you look at it in that case, the communication must be different because it's no longer two ways. The bird obviously cannot communicate with the UAV. Now, I'll leave communication and the problem of communicating with birds to other experts. However, I will focus more on the scientific approach of preventing collision through the use of sophisticated yet reliable camera and sensor systems. And the final issue here deals with scalability. Scalability is this whole idea that whatever you have should be multiplied by 10, or whatever you have should be multiplied by 100. I think you get the idea. Basically, it's this idea that whatever you have should be multiplied by some factor of x. Now, the tricky thing about this is you have to be able to accommodate the scaling factor without compromising on anything else, like efficiency and, more importantly, safety. I think scalability is a really, really big idea because if we plan to leverage this kind of technology, we have to be practical, which means ensuring a certain level of scalability and flexibility for the number of UAVs that will be deployed in roaming our airspace. Logically, we just can't have a couple of UAVs performing all the tasks. Just ask yourself this: would you rather have a handful of UAVs doing all the heavy lifting, flying all over the world, just for a condensed airspace and a less complex UTM? Just something to keep in mind. So that's just the rundown of some of the issues that we could potentially be facing with the widespread adoption of UAVs in the future. In my next video, I will be delving deeper into the specifics of UTM, focusing primarily on two very important issues: automatic issue identification and automatic task distribution. Thank you.